You often buy a product at a dispensary, whether it's flower, gummies, concentrates, something, and it's going to be labeled as indica, sativa, or hybrid. Now, these terms are typically used not to describe the plant that was actually growing, but describe how that product is going to make you feel. So this is kind of just traditionally speaking, an indica is referred to like indicouch, very sedating and calming. A sativa is going to be very uplifting and energizing, and a hybrid is going to be somewhere in between. Now, these terms still are very useful when describing how that plant grows, what the morphology, what it looks like when that plant is growing. But is it really a good way to describe the effects that we're going to feel from a product? That's what this whole video is going to be about. This video specifically is going to be talking about this paper that came out a couple of years ago. This is not the only paper that has discussed the chemical rationale behind the indica sativa hybrid conundrum, but it is one of my favorites because of the different figures that they use, which we are going to discuss. But what is the most important to understand about all of this conversation we're having is that if a plant consistently was a sativa or an indica, if we consistently had those products, we should expect to see some consistent chemistry that would describe those effects. So, for instance, if you have coffee that has caffeine in it and coffee that does not have caffeine in it, that's decaf and regular calf coffee, the caffeine is always going to make you feel stimulated where the decaf is not. That is a chemical rationale for how you're feeling from that product. We should be experiencing kind of something similar with cannabis. Except with cannabis, we're not really looking for one distinct molecule. We're looking for trends. So if we were to take all of these different flowers or these buds that different dispensaries are selling, and we were to look at the chemistry of all the different sativas and all the different indicas, we should expect to see some consistency. Because if sativas really were uplifting and indicas were really sedating, there should be some sort of chemical rationale for why that is the case. And that is the entire basis of this paper. So it's not just going to look into the cannabinoids, but it's also going to look into the terpenes that make up these different flower products from dispensaries. When we think of cannabis, we need to think of it as a mixture of many different molecules. It is not one thing. Every cannabis variety is going to have different levels of all these different cannabinoids, which are things like THC, CBD, CBG, etc. These are all your cannabinoids. That is a class of molecules that is usually responsible for the effects that we feel from cannabis. But there's also other types of molecules in cannabis plants. Specifically, the terpenes have gained the most attention. So terpenes are these smelly molecules in cannabis. So if I had 5 jars of weed in front of me, I would smell them all and they would all smell differently. And this is because each one of these has a different ratio and concoction of these different terpene molecules. So terpene molecules are smelly, but they also have some activity in our bodies. So just like THC and CBD, these molecules can bind to specific receptors in our body and cause specific outcomes like being energizing and sedating. Some are also known to have antimicrobial activity against bacteria or fungi. Some are also known to have antioxidant activity and many different uses. But what we're really going to focus on is just trends. What do we see when we look at indicas, sativas, and hybrids? And is there any way, just looking at the chemistry of these different flower types, is there any trend that we see that would help describe if something is uplifting, sedating, or somewhere in between? So this paper is titled The Phytochemical Diversity of Commercial Cannabis in the United States. And just for background knowledge, phytochemical, phyto meaning plant and chemical meaning a molecule. So this is talking about the molecules produced by the plant in dispensaries and how we can evaluate that. This is an open access article, so not only are we going to talk about it, but I'm also going to link it below in case you want to read it for yourself. Look at these figures a little further and share it with your friends. All right, let's dig right in. We're going to look at figure 1. We're not going to spend a lot of time here because this is not where it's the most interesting. But what I do want to discuss is first in figure 1A, you'll see that the average amount of THC in commercial cannabis products is around 17%, specifically in cannabis bud. Now, this is reasonable, specifically when you're thinking about like how that plant is producing molecules and how much energy they have to put in. 17% seems very reasonable, whereas sometimes you go to dispensaries and see flower that's marketed as like 35% THC. To me, that is not desirable because 35% THC to me means that that plant is putting most of its energy towards THC and not through producing all these other diverse molecules. But this paper actually addresses that too. So then if we look at figure 1B, which is right here, this is just mapping CBD versus THC in these different flower varieties. And what you'll see is the vast majority, about 96% of samples are THC dominant varieties. Because of this and how skewed the market is towards high THC varieties, that is what the rest of this paper is going to focus on, is specifically looking at the chemical composition of high THC varieties of cannabis products. And just a side note, it is very difficult to find balanced strains in dispensaries or cultivars, whatever you like to call them. I'm typically looking for like a 50-50 mix of CBD to THC, and that can be really difficult to find. So, if you do want a more balanced product, you can definitely think of just adding in some hemp to balance out the THC if you're someone who doesn't like to be overwhelmed by THC. All right, let's jump to figure 3. First, if we look at figure 3A, what this is really describing is just the relative abundance of these different terpenes throughout all these different strains that these authors analyzed for their chemical complexity. So we see that myrcene, beta-myrcene, is the most abundant terpene that they measured. So measured all of these other terpenes that are in these samples. So from most abundant to least abundant, we're just going to name the first 4. Beta-myrcene, beta-caryophyllene, limonene, alpha-humulene, pinene, and linalool. What's really cool here, though, is figure 3B and 3C, which is something I think a lot of us knew, but we didn't really have data to support it. But this is a really great way of outlining it. So essentially, this is just comparing two terpenes. Both B and C, these graphs are comparing different terpenes. So first we have figure 3B, which is comparing beta-pinene with alpha-pinene. So these are really, really similar molecules, but they have a slight different configuration of the atoms in that molecule. So they're going to be slightly different. But essentially, the same enzyme in that cannabis plant is responsible for producing both alpha-pinene and beta-pinene. Because it's the same enzyme and it produces them in similar ratios, when you find a cannabis flower product that has alpha-pinene in it, you can expect it to have beta-pinene in it as well and at similar levels. This same trend is highlighted in figure 3C here between alpha-humulene and beta-caryophyllene. So these are larger terpenes. Alpha-humulene and beta-caryophyllene are your sesquiterpenes. So they're just larger molecules. But again, it's the same enzyme that's producing both of these molecules, and you can expect to find them in similar quantities in that plant. Which is really interesting because if you're talking to someone who really enjoys the effects of beta-caryophyllene, they likely also enjoy the effects of alpha-humulene because they're found together. And just a fun fact about beta-caryophyllene, because it's many people's favorite terpene, beta-caryophyllene is actually can bind to your cannabinoid 2 receptor or your CB2 receptor and can be really great for gut inflammation because your CB2 receptors are found throughout your gut. And this is not a cannabinoid, so it's not going to make you feel high, but it can still bind to those CB2 receptors and reduce inflammation. So just a fun fact for people with Crohn's, ulcerative colitis, or any sort of other inflammatory gut bowel condition, I would highly recommend strains that are abundant in beta-caryophyllene. All right, figure 4B is one of my favorite figures in this publication, probably my favorite. But first, we'll start with 4A. 4A is a correlation matrix of all the different terpenes found in this plant. So it's essentially just using colors to show if something is likely found together or likely not found together. I think this kind of setup can be kind of difficult to understand and interpret and read, but 4B kind of solves this problem and really lays it out in an easier to interpret manner. So what we're seeing in 4B here is all the major terpenes that this paper has identified that are abundant in cannabis strains. What's cool though is that all the data in this figure matters. So the nodes are representing the terpenes, so they're different colors. But then the line, the thickness of the line that connects them is showing how they are showing up together in a sample, how often that they're correlated, that they're showing up together. So we just gave the example of alpha humulene and beta caryophyllene. So if we look at this figure here, and I'll put a red arrow next to it so it's easier to see, we see that there's a really thick line between alpha humulene and beta caryophyllene. That means that these two terpenes are likely found together most of the time because the same enzyme is producing them, and it's producing them at similar quantities. You can also see this between beta pinene and alpha pinene, which we just talked about, and also a few other terpenes in this chart. The longer the distance and the thinner the line between these terpenes means that they are less likely to be found together because they're made genetically through different pathways. So you can kind of see these different clusters happening, these up here versus these down here, which is kind of an interesting prelude to if there is rationale behind these different chemical diversity, making you feel different ways with these different terpenes. All right, so this is where the paper starts to get a little wild and we really start to dive into the indica sativa hybrid conundrum. So this graph has so much data in it. It looks kind of simple, but it's not. This is dozens of different dimensions. This is looking at all the chemistry of these different flower types, looking at all that data, and we're grouping it on what we call a PCA plot, or principal component analysis. PCA plots are a little mind-blowing with how much math goes into them, but essentially using all of these different factors, we're plotting them essentially based on variance explained, and then the color that each of these are labeled is due to which terpene is the most abundant in that sample. So what is the dominant terpene in that sample? Because remember, all of these are looking at high THC cannabis. So we don't need to label based on THC content or CBD content because we know it's all high THC cannabis. Instead, we want to focus on terpenes right now. So we're going to label these based on their dominant terpene. So we can see like the orange cluster at the top, that is dominant in terpinolene, which is my favorite terpene, but that these are dominant in terpinolene, linalool at the bottom, we have beta caryophyllene on the other side, etc. So you can see that they're kind of clustering in different ways. So after taking that data, the authors decided to essentially use clustering algorithms to see, unbiased, how that algorithm would decide to cluster this data based on the chemistry alone. So I know that can be kind of confusing, but pretty much everywhere in our life, we see clustering data. On all these different social medias, on everything we see, we're always just clustered in these different things. So using these clustering algorithms, the authors were able to feed in this data, and what was fed out is what you see in figure 6E, that essentially is showing that according to that algorithm, a good way to cluster these different cannabis varieties based on chemistry alone is in 3 different groups of molecules, or 3 different cluster types. This is all just based on that data and what the algorithm thinks is the most reasonable way to cluster this data, which 3 is kind of funny because we already have indica sativa hybrid, which is already a 3-tiered system. So this graph is showing that cluster 1 would be this like fuchsia color on the bottom left, cluster 2 would be this dark purple color on the bottom right, and then cluster 3 would be this orange cluster on the top. And what these really correspond to is cluster 1 is dominant in caryophyllene and limonene. as well as some other terpenes in there, but this is what it's dominant in. Cluster 2 would be myrcene and pinene dominant strains. And then cluster 3 is terpinolene and myrcene dominant strains. Also, just keep in mind that myrcene is the most dominant terpene, which is why we see it showing up more than the others. So I would be a little curious how this data would look if we actually removed myrcene from the data set and just saw how it clustered otherwise. But that's beside the point. Okay, so here's where it gets crazy. So we just showed how, based on the chemistry alone, how computer algorithms would cluster all these different strains of cannabis just based on the chemistry. So the similar ones are clustered together, and all these colors are like perfectly segmented, right? So we have cluster 1, cluster 2, and cluster 3, based on chemistry. So if the hypothesis that different indicas, different sativas, different hybrids, if there really was rationale behind these different types of cannabis making you feel differently, and there was any chemical rationale behind this, we should expect when we change the color that's denoting all this data, when we change that to represent if it's indica, sativa, or hybrid based on how it was labeled at a dispensary, we should see some sort of similar clustering, right? Like indicas should cluster together, sativas should cluster together, and hybrids should cluster together. So this is figure 6A, and what you can see is that is absolutely not the case. We see that indicas are purple, sativas are red, and hybrids are green. We should see clustering if the chemistry really did describe the feeling that was happening in our bodies, and we're really not seeing that. The only statistically significant portion of this graph that's showing any clustering is this little island of sativas over here, which are responsible for strains that are dominant in terpinolene, such as Jack Herrera and other Jacks and Hazes that you can find on the market. I think this is really, really, really interesting. Here's a little side note. I'm always publicly saying that Jack Herrera is my favorite strain of all time. It makes me the most productive. It makes me the most energetic person ever. So whenever I am at a dispensary, I look for things with similar chemical profiles as what Jack has to offer. This was so validating to read that there is chemical rationale for terpinolene, the dominant terpene in these strains, being clustered with the sativas from how they were labeled at the dispensary. That's really awesome. But statistically speaking, indicas, hybrids, nothing else was really clustering together. They're all just kind of mishmashed together on this graph, and there's really not any significant trends that we're seeing. Okay, so let's go back to the graph that kind of perfectly divided based on the algorithm into these 3 distinct clusters, because instead of just looking for an indica and looking for a sativa and looking for a hybrid, if you're really trying to find what cannabis variety works best for your body, I would highly recommend trying one from each of these 3 categories that we're about to discuss, taking good notes and understanding if any of these 3 clusters works best with your body. So looking at cluster 1 first, we see that it's dominant in caryophyllene and limonene. We also see kind of moderate levels of myrcene and humulene. Again, we know humulene and caryophyllene cluster together, so those are always going to be found together. But these are like the general profile that you want to be looking for strains that fall within cluster 1. Your group 2 or your cluster 2 varieties are going to be most dominant in myrcene, but they're also going to have caryophyllene and pinene present and a little bit of humulene. So these are going to be your cluster 2. I'm going to put some different strain names on the actual screen here if you're interested in trying some of those. And I'll do this for each of the clusters. The only issue here is that strains aren't really regulated at all. Like there is no required consistency if you're growing gelato or if you're growing wedding cake. So unfortunately, We can give strain suggestions, but at the end of the day, the most valuable thing that you can do is really start to understand the chemistry and these cannabis varieties, and hope that you go to a dispensary that is super transparent about the chemistry in their products, so that you can start looking for products that are dominant in terpinolene or caryophyllene, etc. But as a good starting point, we're just going to put the strain names here because it can be really overwhelming to think of all this stuff. So it's a lot easier just to say, I'd like to try wedding cake today, or, go to Leafly and look for, dispensaries near me that have wedding cake. So, one step at a time. Once you find a product in a category that you like, just start really exploring that category more and try to find similar products and really narrow down which products work best for your body or the ailment that you're trying to help with. The last category is your terpinolene dominant, your cluster 3. I cannot even describe how different terpinolene dominant cannabis feels to any other cannabis product. It is so stimulating. A lot of people don't like it because it doesn't make you feel as like traditionally high. It doesn't make me feel lethargic at all, but it's very important to note, like I'm saying my personal experience here, but even though we have chemical data to support this, even though I have pharmacological data to support this on myself, if you try the same product, the same strain, you may react differently to it. So it's really important that you take your own notes, you try products for yourself, you always start with a low amount, and you start to just really start to understand your body. So these cluster 3 types are terpinolene dominant. They still have some caryophyllene, some myrcene, some pinene, but it's really that terpinolene that makes these products different than any other flower products on the market. A couple things to note, because this paper is really just looking at the chemistry based on what testing labs are already looking for in cannabis. And here's some things to note. I mean, one, when you smoke anything, the chemistry completely changes. So although this paper is looking at the chemistry in the raw flower, we know the chemistry is completely different when it's combusted. And that's something that's not very easy to study right now. And I would never expect a paper like this to actually evaluate that, but it's something to keep in mind. 2, there's always things we're not measuring. I mean, this paper is specifically looking at high THC cannabis and looking at the terpene profiles, but it's important to note that there are minor and rare cannabinoids. There's minor and rare terpenes. There's compounds that are kind of conglomerates of multiple things that are in these plants at really low levels. And although we don't monitor, we don't test, we don't report on these, they are likely present in this plant at low levels, and we are still taking them in our body, and they could have profound changes that we just don't have a way of measuring right now. But what's important is we're discussing what has been done, and when new papers come out, we will discuss what new papers are doing, and so on and so forth. I'm actually going to upload a completely separate video that goes into the data on why it's difficult to trust strains to be consistent from dispensary to dispensary. So hopefully that'll be up next week, but I hope this video has taught you one thing, and that's you can't just trust indica sativa hybrid. Although I wish it was that easy, and sometimes maybe that might be accurate, it can be very misleading. I mean, we oftentimes look at just the genetics and not the chemistry, and it's really not a good descriptor because cannabis has been bred for so many years that it's really changed the, what products, what compounds are dominant, and really what's being expressed by that plant. So my recommendation would be this: to try a different product from each of these clusters, a different flower type from each of these clusters. We know, just based on this data and some statistical significance, that strains that are dominant in terpinolene are likely going to be more sativa-like, more uplifting, right? So if we put that up here as your uplifting, definitely try some, like Jack Herer, try Ghost Train Haze, try these different products, and I'll put some different strains to try if you're interested in that here. Other clusters, because they don't really group towards sativas or hybrids, it's most important for you to just try these products and note how it makes you feel. Even better, if you can afford it, which not everyone can, try a product from each of these categories like 3 days in a row. So that way you can immediately really feel the difference between these types of products, and you can take notes. Your body's going to be at a similar place when you try all of these, and you can really start to understand like, oh, these cluster 1 types really give me anxiety. I really don't like those. My body doesn't react well to them. Cluster 2, I felt really lethargic. I felt relaxed. I felt creative. Cluster 3, I felt really energized. I felt amazing. I would definitely try that again for daytime cannabis. You don't need any fancy journal to record your thoughts. I sometimes even put like stars, like 2 stars, 3 stars, and then like a sad face or a happy face if I'm feeling lazy. It doesn't need to be super scientific, but I think just recording how things make you feel is the most important. So try these products out. If you have any personal experience with any of these, feel free to comment. I think this paper is really cool because it's really linking like modern day chemistry to like the traditional market of cannabis. And I know a lot of people are like, why does it matter? I'm just weed is weed, whatever. A lot of people are using cannabis for medical purposes, and you really got to hone down on how a product makes you feel. You might need to hone down on what's your daytime product, what's your nighttime product, what's your weekend product, what's your painting product. And taking notes and trying different products can definitely help you. Also, for any bud tenders out there, if you can even try to mentally note 1 strain in each of these categories that you could help recommend different people to, like if people say, I'm looking for a product that's dominant in caryophyllene, have something in your head to say, okay, I'm going to recommend this strain when people come in to try a product. And I think together we can really get somewhere eventually. I want to keep just talking about the research and making this accessible to everyone because it's 1, incredibly cool, but 2, incredibly helpful for just helping us hone in on how we use this amazing plant. Also, please subscribe to this channel for no other reason than it helps me make money. Everything I do is free at this point. So even just hitting subscribe and watching these videos helps a ton. And I love doing it. So thank you for watching. Mad love. See you next time.